Okay, I've started recording also. And let me share my screen. All right, good. So let me go to your sharing. Okay, so box. See these two. Open with. Okay, good. Okay. Can I ask you if I have talked about this type of question with you? So let me open the PowerPoint first. So, okay. So, okay. So, for example, you have, okay, let's say you have two containers. Okay. Same size, and maybe no fee. Okay. You have two containers of the same size, and let me give you the dimensions. So you have 10 cm here, 10 cm here, 5 cm for the breadth, and then 8 cm for the height. Okay, so the container A is empty. Container B starts with some water. Okay, and the volume of water inside container B is let me see, 50 cm cube. All right, and the rate. So you have both tab A, and then you have tab B, and the rate of tab A is 10 cm cube per minute, and the rate of tab B is 5 cm cube per minute. Okay, and the question asks how long does it take for both tanks to reach the same height? Did I discuss this question with you before? Or you have any idea how to answer this question?
Yeah. Yes.
So we discussed this question before?
Yeah.
Okay, good. So can you figure out what's the answer quickly? So before you answer me, you have to unmute yourself.
Two minutes.
2 minutes. Okay. I don't know how you I don't know how you get the answer, but if your answer is 2 minutes, you are wrong. Okay, but it's okay. So let me discuss this question with you one more time. Okay, by the way, there are two methods. There are two methods to solve this question. Okay, I'm going to demonstrate to you these two methods. Okay, it's okay if you get it wrong. So the first method I'm going to use is I'm going to use the table method. Okay, I'm going to use the table method. And let's see how I can use the table method to solve. Okay, so what do I have? I have a tank A, and I have tank B. Okay, and after that, the initial volume of water, for tank A is 0, and then the initial volume of water in tank B is 50. Okay, so let me put the unit here so I don't have to put unit below. All right, and what should be the heading of this column is rate. Okay, rate. So for tank A, the rate of water going in is 10. Okay, for tank B, so the rate of water going in is 5. Okay, and then after that, the heading for this column should be time. Okay, and oh, looks like I think I need to add one more column to it. So let me insert one more column to the right. Okay, good. So after this will be the volume of water by the tap. Okay, and then of course this will be the final volume of water in the tank. Okay, good. So first thing first, do you understand why I put the headings as such? Do you have any question on the headings?
No.
No. Okay. So, okay. Can I ask you a question? Why I need to differentiate volume of water by the tap and the final volume of water? These two. So why I need to split these two? Any idea?
Because the initial is different.
Correct. So in fact, what I want to find out is, I want to find out what is the volume of water by the tap alone. Okay. Then the final volume of water for the last column here should be, this one should be the tap plus the initial. Right? So basically the volume of water from the tap plus the initial will give you the final volume. Okay, so now the volume of water by the tap is given by what? The volume of water, probably I need to use a different color. So because I feel that red color is not very good. Okay, so let me just use another color. So the final volume of water is given by the tap plus the initial. Okay, and volume of water by the tap is given by the rate times the time. Okay, so I hope you can see the these two headings, they are given by two different formulas. Okay, so volume of water by the tap is rate times the time. Okay, so now the question is how long does it take for both tanks to reach the same height? So if you were to so basically if you want to draw it out, so basically let's say they will reach the same height. Okay, so this is what you can actually draw on the diagram. So let's assume basically the water will reach the same height about here. Okay, so therefore the time taken, which I don't know, which the question asks for. So what you can do is you can actually take the time as t. So time t for tank A. So similarly, time t for tank B. Okay, because how long does it take for both tanks to reach the same height? So they run for the same time. Okay, now so volume of water by the tap A is given by 10 times T. Okay, for tank B, volume of water by the tap B is 5 times T. Okay, so with this, I think you can find out the final volume of water. So the tap is 10T plus initial. So in this case, the initial is 0. Okay, initial is 0 for tank A. And then for tap B, tank B is 5T plus 50. Okay, so with this, I think you can actually do what? You can actually form an equation. Okay, the equation is, so let me change the color. Okay, so the equation will be 10T plus 0 equals to 5T plus 50. Okay, so given this, so it's 10T minus 5T equals to 50. So 5T equals to 50. So T equals to 10. So it takes 10 minutes. Okay, so yes, it takes 10 minutes for them to reach the same height. Okay, cannot.
Can
So
I just
pardon?
Can I just write 50 divided by 10 minus 5?
I thought 50 divided by 5. Why 50 divided by 10?
Minus 5.
Yeah. So 50 divided by 5. Yeah. So the answer is 10. Okay. But just now your answer is 2, right? You said.
Yeah.
Oh, okay. So this is method 1. Okay. So I'm going to demonstrate to you how you can actually use method 2. Okay. I think we have discussed method 2 before. Okay. So method 2 is very simple. Okay. So basically at the start, the difference between the two is 50 cm cube. Okay. So in order to make up for this, this 50 cm cube difference, okay, so you have to look at the rate between these two taps. Okay, so I think you can see that after 1 minute, okay, tap A can actually make up 5 cm cube. Okay, so after 2 minutes, you can see that tap A can actually make up 10 cm cube. So therefore, the question you ask yourself is, in order to make up 50 cm cube, what is the minute? So 50 divided by 5, which is 10. All right, so this is an easier method to get the answer. Okay, so far so good.
Yes.
Good. So the answer should be 10 minutes. Whether you use method 2 or method 1. Okay, so both methods work. Okay, so this question I will say is quite a difficult question, but it's not the hardest. Okay, so let me give you a modified question, okay, of this question. Okay, let me give you a modified version of this question. Okay, so okay, let me just write down 50 cm cube. So no change, but now there is this change. So instead of 10 cm, let me make it smaller. Okay, good. So this is not. So 8 cm, 5 cm. This is 5 cm. Okay, so now the question is, same question. So how long does it take for both tanks to reach the same height. Okay, so how does this question differ from that question? Okay, I hope you can see that the dimensions between the two, they are different already. So how does this change in dimensions affect the answer? So please attempt this question. Or you have any idea how to do this question? You have any idea? You need to unmute yourself. Can't hear you.
Is it divide by?
It's okay. So I will let you figure out the question first. Then once you have figured out the question, and then I will just help you verify your answer using my method later. Okay. So go ahead and figure out the question first.
Is it 30?
So you say the answer is 30 minutes. Am I right?
Yeah.
Then can I ask one more question? So what is that height they both reach after 30 minutes? If the answer is 30 minutes. So can you answer part B as well? I have not figured out the this question yet, so I will figure out after your answer. So let me know if you have figured out part B as well. How come it takes you a bit long? It shouldn't take you very long, actually.
I don't know.
Okay, good. So if you don't know, so that means your this answer 30 minutes is very very doubtful. Okay, so let's look at the question together. So let me get rid of this. Okay, so let me demonstrate to you. You can actually solve this question by two methods. Okay, so number one, I will use the table method. Okay. Okay, so in this question, okay, in fact, the question asks, how long does it take for them both to reach the same height? Okay, so what you can think of is, so probably they will reach the same height somewhat here. Okay, so you have to find out what is the what's the length what's the height. Okay, here. Okay, so the question here is because of the difference in dimensions. Okay, so you cannot make use of the idea of volume here. Okay, so if you look at the question just now, so this is the question where tank A and B, they have the same dimensions. So you can make use of the concept of volume here. Okay, but for this question, because of the difference in dimensions between A and B, you cannot make use of the concepts of volume. Okay, so you cannot make use of the concept of volume. So instead, the question here is you need to make use of the concept of height. Okay, for this question. Okay, just now, same dimensions, you can make use of the concept of volume. Over here, you need to make use of the concept of height. So number one, so let me fill in. This is A, this is B. So this is initial height. Okay. I'm going to make use of the concept of height. So the initial height for A is 0. The initial height for B is, how do you find out the initial height for B? You make use of this. Okay, so you already have 50 cm cube of water inside. So you divide by the base, which is 10 times 5. Okay, so you get 1 cm. Okay, so basically the initial height of water in tank B is 1. So I'm going to put 1 here. Okay, and then of course the next, okay, the heading here is instead of just now I put in rate. Okay, rate is the flow of water. So in this case is rate of height. Okay, it's not rate anymore, it's rate of height. That means how fast the height changes. Okay, how fast the height changes. Okay, so it's actually, to be more precise, is rate of change of height. Do you understand why I put rate of change of height instead in this case?
Yes.
Okay, if you don't understand, please voice out. Okay, I know some of the concept here might be very alien to some of you if you have not encountered. So at any point, if you don't understand, just voice out. I'm going to explain to you in a simpler terms, so don't feel shy. Okay, so since you said you understood it, so I will just continue. So instead of rate in the previous question, so I put rate of change of height. So over here, I'm making use of the concept of height. So now this will be time. Okay, then of course this will be the height. This is not the final height, so this is the height by the tabs, okay, or by yes, the height by the tabs, and then this will be the final height. Okay. So I hope you understand why I put height by tabs, and then I also need to put in an extra column here for final height. Okay, so let me fine tune it a bit here first. Okay, looks good. Looks good. Okay, so just to make sure you understand more, so the final height here will be height by tab plus the initial height. Okay, so let me just, sorry, just use short form. So this h by tab plus the initial h. That will give you the final height. Okay, so the rate of change of height for A is, how do you get that? How do you get the rate of change of height by tab A? Can you tell me how?
10 divided by
10 divided by what?
5 and 5.
So 10 divided by 25. So what do you get? 10 divided by 25. What do you get?
2/5.
Okay, which is 0.4. Okay, so basically every minute the change of height for tank A is actually 0.4 cm. Okay, so what you have done here actually, what you have done here is you are taking the rate divided by the base area 5 times the 5. Okay, so you get 0.4. Okay, very good. So what about the rate of change of height for tank B is 5 divided by 50.
5
5
is
divided by 50,
0.1.
0.1. Okay, so you get 0.1 in this case. So what you do next is, so basically they run for the same time, so time t. Okay, so now you can have height by the tabs is 0.4 t for tank A, and this is 0.1 t for tank B. Then with this you can actually get the final height. Over here is plus 0, over here is plus 1. So you know what to do, right? After that, what you do here is you just equate these two, and can you help me figure out what is the answer? Okay, can you help me out? Okay, if the meeting is ending in 10 minutes later, so we will just log in again and just Okay, can you help me out? What's t given this equation? Looks like you get a fraction, right? It's okay, so we just stick to the fraction. So what's the answer?
3 and 1/3.
3 and 1/3. Okay, so that means 10 over 3, right? This is in minutes, right? Am I right? So you can actually express it in seconds. So 10 over 3 times 60 is 200 seconds. Okay, so that's how you can get the time. Okay, so okay, by the way, that's the reason why I want you to understand method 1, which is the table. Okay, so I want you to see that, because some questions, right, for some questions it's easier to understand using method 1. Okay, that's the reason why I want to demonstrate to you in method 1 and method 2. Okay, because I see that sometimes it's easier for you to understand or easier for you to get the answer using method 1. Okay, so for this question, I think it's easier to get the answer by method 1. Okay, method 1 might look a bit more complicated. Actually, it's not. Okay, method 1 is just I will say you have to write more things. Okay, when you need to write more things doesn't mean it's more complicated. Okay, it's not true. Okay, so if you manage to form this table, fill up the table, it's so easy to understand. Okay, Ken?
Okay.
So I think it's better to stick to method 1 to solve this question. Okay, when you have different dimensions. Okay, so for method 2, so let's not discuss method 2 because I think for method 2 it's harder to understand the question. Method 1 is easier for you to understand the question. So I will just stop at method 1 for this question. So yes, so basically this modified version of this question is actually the hardest question you might face in your exams. So please make sure you understand this question because if it ever comes out in your exam, so you should have advantage over others. Okay? Okay?
Okay.
Good. So let's move on to your homework. Okay, so like I say, if the Zoom meeting is ending in I think about 6 minutes, so we will just log out and I will just log in again. Okay, so it takes less than a minute. Okay, so let's look at this paper. So good. Okay, so very good. So you score full marks for the MCQs. Oh, by the way, just to share with you, not to give you pressure, just to share with you. So Yusing is also picking up. Okay, Yusing is also picking up. So basically she starts to hold on. Can you just put the foot outside? Thank you. Yeah, the table, the shelf, please. Thanks. Okay, so yeah, I just got my delivery. But anyway, so yeah, Yusing is actually picking up. So she's also she starts to do well for math, which is good to see. So for you, please please keep at your this very high level. Okay, so I want my students to do very well in their exams. Okay. Okay, question 19. Find the sum of E10. Oh, this one you just have to read the question carefully, and then of course, so tens, right? So you have 11 times tens. 1, then this 1 over 10. 10 times 1 over 100. So what you do? Are you allowed to use calculator? If you can use calculator, you just add them up. Are you allowed to use calculator or not?
Only paper 2.
Oh, okay. But this one should be 0.1, right? 10, 10 times 1 over 100. So you get 0.1. So if you add these two, should be 110.2. Oh, so don't make this silly mistake. This is not 1, this is 10. Okay. So what's wrong with this? A box measuring this. I want to pack identical cube of ages. Can I ask you, did you use this method once again? Don't tell me you use this method.
No.
Oh, okay. So hopefully you don't. You cannot actually. You know why you cannot use this method?
Because there's extra space and that can form into one cube.
So basically, right, if you use this method, right, basically you fully so basically if you use this method, right, you are actually you cannot lah. So basically, if I try to label this box out first, and I explain to you why you cannot. So first thing first, for this 6 cm. So we make all 6 cm. Okay, good. So basically, you need to find out how many 6 you can put here. So you realize you only can put 6 of them. So how many 6 you can put here? You realize you can put 8 of them. So how many 6 you can put it here? So you can put 10 of them. Then you just times them together. Okay? You can pack a lot more, right? Yeah, so 6 times 8 times 10. You can pack. I don't know how you get 24.
I
Oh.
added.
You add. Okay, so so basically you have 6 of them here. Okay, then you have, I don't know why you add. When you add them, basically you're telling people you only fill up the first layer, you know. Okay, but you still have 10 layers. You know that you have 10 layers. Okay. Can? Okay, so it's in fact, right? Once you sketch this out and you realize you're not supposed to add. Okay. If you sketch this out and you realize you're not supposed to add them up. Okay, you're supposed to times them. Okay, so never use this anymore. This is a very common mistake by students. Okay, so basically when you make use of this concept, right? So when you make use of this concept here, okay, which is wrong. So what you assume is basically all the spacing here, right? All the spacing here, okay, you will add all the spacing together, and then you make use of the spacing to divide by your this 6 times 6 times 6. Okay, and you realize all your this spacing cannot be combined together to divide by this, because all this spacing here actually they are unused. Okay, they are unused and they cannot be used. All right, but when you use this concept, okay, when you use this concept, what you are actually doing is you add all this spacing left over, you add them up, and you still go ahead and divide by this. Okay, you can't do it in real life. All right, so the answer is 480. Okay, next. 23, you are correct or wrong?
Wrong.
Wrong. Okay, so let me log out and log in again. So looks like I run out of time for the Zoom meeting. Okay, so let me log out first. I will log in again. Okay, less than a minute. Okay, I will log out first. I will log in again.